Hi everyone, welcome back. In this video, we can understand Spring Boot application architecture. Here we are going to use 3-layer or 3-tier architecture to develop our Spring Boot applications. Spring follows a layered architecture to simplify application development by providing auto configuration and embedded servers and production ready environment out of the box. Here we have layers such as controller layer, service layer, and persistence or DO layer. First one is controller layer. It is also known as API layer. It handles HTTP requests through REST controllers like get, post, put, and delete. And it manages authentication and request validation and JSON serialization or deserialization. And also forwards the process request to the business layer for further logic. And next one is business layer. It is also known as service layer. The business layer is responsible for implementing application business logic. It has service classes that can process and validate data and handles authentication and authorization if you use security and applies transaction management. And finally, it interacts with the persistence layer to store or retrieve data and persistence layer. The persistence layer manages database transactions and storage logic. It has repository classes that uses Spring Data JPA and Hibernate for data access. And this layer is responsible for managing Java object to the database records using ORM frameworks and managing CRUD operations like create, read, update, and delete operations, and also supporting relational databases and NoSQL databases. Here we are using Postman as a REST client. Here the actual request flow is whenever the client makes the HTTP request like get, post, put, or delete to the application, then the request is handled by the controller layer and which maps the request to the specific handler method. Here the service layer processes the business logic and communicates with the persistence layer to fetch or modify data. Here the persistence layer interacts with the database using Spring Data JPA. Finally, the processed response is returned as a JSON format. This is all about Spring Boot application architecture. Okay, I will see you in the next video. Hi everyone, welcome back. In this lecture, we will create and set up Spring Boot project. We can create the Spring Boot application using Spring Initializer. This is the Spring Initializer website. Here we can provide the details and select the required dependencies. Finally, we can download the project and import the same project in the IDE. That is one way. We can also create the application using IDE. I am using STS IDE to create the Spring Boot application. Now let's create the application. Go to File, New, Spring Starter project. Here we can provide the name of the project, that is Spring Boot e-commerce REST API. I am choosing Maven as a build tool, packaging as jar, selecting Java 17 version, language is Java. Here I am using group ID is com.springboot.ecommerce. Here I am using this group ID and artifact ID is same as application name, and we can provide description that is Spring Boot e-commerce application REST APIs, and package name is com.springboot.ecommerce. Click next. By default, Spring is using 3.5.7 version, and here we can select the dependencies. Here I am choosing Spring Web. By using Spring Web dependency, we can build web and REST applications, and it will internally use embedded server, that is Tomcat server. Here I am choosing Spring Web, and we can use Spring Data JPA. Spring Data JPA. By using Spring Data JPA dependency, we can create DAO layer, that is persistence layer, and Spring Data JPA internally uses Hibernate as a JPA provider. To implement persistence layer, we are choosing Spring Data JPA dependency. Then we can choose MySQL driver. In order to communicate with the database from the Java application, we need driver. So that's the reason we can choose MySQL driver. And then we can choose Lombok dependency. This is project Lombok. By using Lombok dependency, we can reduce lot of boilerplate code like getter methods, setter methods, constructors, and so on. So let's select this dependency. And also we can choose one more dependency, that is Spring Boot Dev Tools. whenever we do some changes in the Spring Boot application and we no need to explicitly restart the application, this dependency will take care restarting application. For that, I'm using Spring Boot DevTools dependency. And we are going to use Spring Security dependency. As of now, let's keep these dependencies. Whenever we integrate Spring Security in our Spring Boot application, that time we will add Spring Security dependency. Okay, click Next, click on Finish. Now the application is getting created. Let's open the Spring Boot application. src main Java. This is the root package. Open this class. This is the main class. Spring Boot execution will begin from this class. By using this starter class, we can run our Spring Boot application as standalone application. And we have pom.xml file. This is parent starter with specific version. And this is the Java version. And it contains all the dependencies. This is Spring Data JPA dependency. This is Spring Web dependency. This is DevTools, MySQL driver, Lombok, and test dependency. These are the dependencies we have chosen while creating Spring Boot project. Okay, in next video, we will create the packaging structure for our Spring Boot application. Okay, I will see you in the next video. In previous video, we have created Spring Boot project with required dependencies. In this video, we need to create Spring Boot project structure, that is also known as packaging structure. Before creating Spring Boot packaging structure, we will take a look into our Spring Boot project architecture. This is Spring Boot application architecture, 3-tier or 3-layer architecture. And most of the developers prefer 3-layer architecture for the Spring Boot projects. We will use 3-layer architecture as a reference for creating packaging structure. For example, for controller layer, we'll create controller package and we'll keep all the Spring REST controllers and we'll define REST endpoints. And in the service layer, we'll keep all the service classes. And basically, service classes holds business logics. And DAO layer, it is also known as repository layer. In repository layer or DAO layer, we will create repository package. And we'll keep all Spring Data JPA repositories inside repository layer. Repository layer will talk with the database. And at the database layer, we will use MySQL Database. According to Spring Boot project architecture, we will create packaging structure. Okay, let's go to STSID. Under src main Java folder, com.springboot.ecommerce is the main package. Here we can create required subpackages. First of all, I am creating one package, that is entity. This is entity package. In entity package, we will keep all JPA entities. Now let's create one more package, that is repository. We will keep Spring Data JPA repositories inside repository package. Then I'm creating one more package, that is service. This is service package. Here we can keep all service interfaces inside service package. Inside service package, I'm creating one more package, that is service.impl package. .impl. Inside this package, we will keep all service classes and also creating one more package, that is controller. We will keep all Spring MVC controller classes inside this controller package. And I'm creating one more package, that is DTO. Basically, in controller classes, we will use DTO classes. These DTO classes will move from one layer to another layer. And I'm creating one more package, that is config package. In this package, we will keep all the configuration related classes and creating one more package, that is utils. We will keep all utility classes inside util package and also creating one more package, that is exception. We will keep all custom exceptions inside exception package. Okay, this is a simple packaging structure in our Spring Boot project. We have created this packaging structure as per Spring Boot project architecture. Most of the developers prefer 3-tier architecture. So we have created packaging structure according to this 3-tier architecture. Okay, in next video, we will configure MySQL database for our Spring Boot project. Okay, I will see you in the next lecture. Hi everyone, welcome back. In this video, we will configure MySQL database in our Spring Boot application so that our Spring Boot application will connect with the MySQL database. Let's first create a database inside MySQL Workbench. Okay, let's move to MySQL Workbench. This is MySQL Workbench. Here we are going to use MySQL Workbench as a client to connect with the MySQL server. Here let me create the SQL statement, that is create space database space followed by database name. Here I'm giving e-commerce underscore db. This is database name. Okay, let's execute this SQL statement. Let's refresh. See here, e-commerce DB successfully created. Let me set this database as default schema. Set as default schema. Here we have successfully created database. This is the database. Now let's configure the database in our Spring Boot application so that our Spring Boot application will connect to this e-commerce DB database. Okay, let's move to STSID, open project, open src main resources, go inside application.properties file. Inside this application.properties file, we will configure MySQL database information. Go to pom.xml file. This is Spring Data JPA dependency. This dependency automatically create the data source and it will refer MySQL database properties from application.properties file, and it will establish the connection between Spring Boot application and database. So that we need to configure MySQL database details inside this application.properties file. Let's provide configuration properties like spring dot data source dot. Here I'm providing URL. Here we can specify JDBC URL to connect with the MySQL database, that is JDBC colon MySQL colon localhost and the port number is 3306 slash. This is the database name. Let's copy this, paste here. This is URL. With this URL, our Spring Boot application will communicate with the database. Now let's provide username and password. Spring dot data source dot username root and password also root. Next we need to configure Hibernate dialect. Spring dot JPA dot database platform, that is MySQL dialect. Simply we can write org.hibernate.dialect.mysql dialect. Open predefined classes, Control Shift T. Here I'm typing MySQL dialect. See, this is the class. This is the package name org.hibernate.dialect. Copy this, paste here. Dot. This is the class name. Copy this, paste over here like that. And we can provide one more property, that is spring dot jpa dot hibernate dot ddl auto. Spring dot jpa dot hibernate dot ddl auto, providing update. This property will tell Hibernate to create the database tables automatically if the tables are not available in the database. This update property will act as, if the tables are not available in the database, then it will create the new tables. Otherwise, it will use the existing tables only. And we need to provide one more property, that is spring dot jpa dot show SQL. This property is optional. It will print SQL queries generated by the Hibernate in the console. And I'm adding one more property, that is spring dot jpa dot properties dot hibernate dot format underscore SQL. Spring dot jpa dot properties dot hibernate dot format underscore SQL is equal to true. It is used to format the SQL queries printed by the Hibernate. It will beautify the SQL query. It is also optional. Now we have configured MySQL database in our Spring Boot application. Let's run the Spring Boot application and let's check whether the Spring Boot application will connect with the MySQL database or not. Let's run the Spring Boot application. Right click, run as Spring Boot application. Observe here, in the console, no errors and no exceptions. That means our Spring Boot application successfully connected with the MySQL database. See here, Hibernate using this dialect. and Spring Boot by default using Hikari data source to make the connection between Spring Boot and MySQL database. Okay, I will see you in the next lecture. Hi everyone, welcome back. In previous video, we have configured MySQL database in our Spring Boot project. In this video, we will create JPA entity for customer resource in e-commerce application. Let's open e-commerce application, srsim in Java. Inside this package, I am creating one class that is customer entity. Customer. Now let's provide the properties like private, integer, id, and the private string, customer name, and then private string, email, and private string address. These are the fields for customer entity. Here I am using Lambda connotations on top of class. Here Lambda connotations will provide getter, setters, toString, equals and hash codes and all at runtime. So simply I am using @data annotation on top of class. This is data annotation. Let's go and set this annotation. See, it provides getter, setter, required args, toString, equals and all. I am using one more annotation that is all args constructor. Whenever we declared all args constructor with the entity, we use @no args constructor. Then Hibernate internally uses proxy to create the object at runtime. And here we will use JPA annotations to map JPA entity with MySQL database table. Here I am using @entity annotation. This annotation belongs to jakarta.persistence package. Here I declared entity annotation on top of customer class. It marks this class as JPA entity. And also I am declaring @table annotation. Here I am providing name, customer underscore table. This is the table annotation. Here I am providing table name. This is optional. If you are not defining table annotation, then JPA will use class name as database table name. If you want to mark the property as unique, then we can use unique constants. Here I am using unique constants, @unique constant. Here I am providing column names. I want to make this property as unique. For that I am using this property here. That's it. If you are not providing table annotation, then JPA will consider class name as table name. Now let's specify primary key to our entity. Here I am using @id annotation. It specifies primary key to our entity. And I am using @generated value annotation. I am using this annotation to specify primary key generation strategy. Here I am providing strategy identity. And also we can provide column names also. For that I am using @column annotation. Column. Here I am providing column name like this. If that field is not null, for that I am using nullable is false. Simply I am using for email. This is email. And this is for address. If you are not specifying column annotation, then JPA will use field name as database table column name. Now we are ready with customer JPA entity. Let's start the Spring Boot application. Let's check whether the customer table is created in the database or not. Right click on the project, run as Spring Boot application. See, this is the customer table SQL query and everything is working as expected. And Tom cursor was started and running on port number 8080. Okay, let's move to MySQL Workbench. Let's refresh. See, the customer table is created here. This is customer table structure. Okay, I will see you in the next video. In previous video, we have implemented customer JPA entity. In this video, we will define Spring Data JPA for customer entity. Let's go to repository package. Inside this package, I am creating one interface. That is customer repository. Here the customer repository extends JPA repository. Here the JPA repository is generic, so we need to pass parameters. Let's go to customer entity. This is entity name. Let's paste here. And this is primary key data type. Copy this and let's paste here. Let's import. Control Shift O is the shortcut key to import packages. This JPA repository belongs to this customer entity. Here we will provide separate JPA repository for each JPA entity. For example, if I want to create order entity, for that we will create order repository like that. Here we no need to write any code because Spring Data JPA has JPA repository interface. It internally provides all the CRUD database operation methods and its implementation for us. Let's go inside this JPA repository. See, this is the JPA repository. JPA repository provides these methods. And also JPA repository supports pagination and sorting. Go here, click this, click on this paging and sorting repository. See here, using this method we can perform sort operation. Using this method we can perform pagination also. Here one more important point is, we are not required to write @repository annotation on top of this repository because this JPA repository internally provides simple JPA repository class. Let's go inside this repository, go to its implementation. See, we have simple JPA repository class. Let's click on that. See, simple JPA repository is a class and it is implementing from JPA repository implementation. Let's click on this. Internally, this JPA repository implementation extending from JPA repository. In simple JPA repository, already it is annotated with @repository annotation and @transactional annotation also. Here we no need to define @repository annotation on top of customer repository. This is not required here. Now we are ready with customer repository. Okay, I will see you in the next lecture. In this video, we will create DTO for customer entity. Before creating DTO, let's take a look into how to use DTOs in Spring Boot application. This is Spring Boot application architecture. DTO stands for Data Transfer Object and it is frequently used design pattern to pass the data in multiple parameters from client to server. Your client is nothing but Postman. Basically, we will use DTO class to send and receive data between client and server without exposing the actual entity. It will hide the sensitive fields like password, salary, and internal IDs and so on. And also it avoids unwanted updates to entity fields. Basically, we are not returning entity directly to the client. We are going to return DTO to the client. In upcoming videos, we will use DTO classes in all the REST APIs to return DTO classes directly to the client. Let's move to STSID. This is the DTO package. Inside this package, I am creating customer DTO class. Customer DTO. Here, let's define fields. Let's go to entity. This is the customer. Based on the client requirement, we can provide required fields. For example, ID, customer, email, and address. Here, I am defining fields like private, integer, ID, private, string, customer name, private string, email, private string, address. These are the fields that I'm using in customer DTO. And on top of class, I'm using @data annotation. This is Lombok annotation. Instead of creating boilerplate code like setters, getters, toString, and so on, it will provide dynamically at runtime. This is the customer DTO class that we will use in service layer and controller layer. Mainly, these DTO classes will be moved from one layer to another layer. We will use this DTO class in service layer and controller layer. I will show you that in the upcoming videos. Hi, welcome back. This is a customer resource design. Here, this is a create new customer REST API. It will handle HTTP post method and URL is /API/customers. And its status code is 201 created. Now let's implement create customer REST API. Okay, let's move to STSID. Under this service package, I am creating customer service interface. Right click, new interface, customer service. This is the interface. In this interface, let's define create customer method. Customer DTO create customer. Here I'm passing customer DTO as an argument. Customer DTO. Here I declared one method, that is create customer method. The return type is customer DTO. Here I'm passing customer DTO as an argument. Let's create service class inside IMPL package, that is customer service IMPL. This class should implement customer service interface. Customer service. Let's override the method. This is the method. I'm using @service annotation on top of class. This is stereotype annotation. This annotation indicates that the class is service class and it marks the class as ping bean. And inside this class we'll inject customer repository, that is private customer repository. Here I'm using constructor based dependency injection. This is the best practice to use. Simply we will use all argument constructor on top of class, that is Lambda connotation. Here I'm using @all args constructor. Simply we can use this. Otherwise we can define parameterized constructor. At constructor level we will use @auto annotation. From Spring 4.x onwards, if we have only one parameterized constructor, then we can omit @auto annotation. And now we need to convert DTO to entity. For that we will use model mapper library. Let's go to browser. Here search with model mapper Maven dependency. Model mapper Maven dependency. Choose first one. I am selecting latest version. Let's copy this dependency and paste inside pom.xml file. Let's move to STSID. Go inside pom.xml file. Inside pom.xml file, let's paste this dependency. This is model mapper dependency. We will use this model mapper dependency to convert one object into another object. Let's close this. Here I am creating opconfig class inside config package. Opconfig. This is normal Java class. On top of this class I am using @configuration annotation. This annotation marks the Java class as configuration class. Inside that I am creating one bean definition, that is public model mapper. I am returning its object, return new model mapper. On top of method I am using @bean annotation. This is opconfig class. Here I declared this annotation. Inside this class I provided one bean definition. Okay, I am ready with model mapper. Let's close this. Here I am using model mapper inside customer service, that is private model mapper like this. Here first we need to convert DTO to entity. Convert DTO to entity. I am using model mapper here. See, go inside model mapper. This is the class. It has map method. This is a map method. By using map method we can convert one object into another object. I am using map method, map customer DTO. I want to convert to customer entity. Customer.class returns customer object. Now I want to save this customer entity using this customer repository. Then customer repository dot, we have save method. I am passing this customer entity here. Let's capture that entity in new object and declaring new customer. After that we will convert entity to DTO. Convert entity to DTO. Directly I am returning model mapper.map. I am using the saved customer, returning customer DTO dot class like this. Now we are ready with customer service. Then we will create customer controller and we can inject this customer service inside customer controller. And we can call this method from controller. Let's close this. Now I'm creating one class inside controller package, that is customer controller. On top of class, I'm declaring at the rate REST controller annotation. This annotation marks the class as REST controller and that return the response in the form of JSON. And it is combination of controller and response body. Let's go inside this annotation. Internally, it is using controller and response body annotation. And also I'm annotating a request mapping annotation on top of class. By using request mapping annotation, we can provide main endpoint URL here, like /API/customers. Now let's inject service class in customer controller. Let's create a field that is private customer service. Here we are injecting interfaces but not classes to achieve loose coupling over here. So we are not tightly coupling with the classes. Here I am using @allars constructor. This is Lambda annotation. I am using this annotation for constructor based dependency injection. Now let's create REST API, that is create customer REST API. Customer REST API. That is public response entity. It is generic type. I am passing customer DTO. The method is create customer. Here I am passing customer DTO as an argument, and here I am using @request body annotation. This annotation is responsible to convert the JSON object into Java object. On top of method, I am using @post mapping annotation. This annotation handles HTTP post requests. Here simply I am returning object of response entity, that is return new response entity. Here we can call customer service. Let's copy customer service dot create customer. Here I am passing customer DTO. Inside customer controller class, we are calling this create customer, and here we can provide HTTP status, that is created. Let's test this API. Right click on the application, run as Spring Boot application. Now the application is up and running and Tomcat server started and our application is running on port number 8080. Let's move to Postman tool to make post HTTP request. This is Postman tool interface. Here we need to construct a post request. Let's go to customer controller. This is a REST endpoint URL. Let's copy this. http://localhost : and port number is 8080, and you can paste that copied URL here. We are changing HTTP method type to post. Basically, we need to provide JSON object in request body. For that, we need to choose body, raw, and choose JSON as content type. Here we can provide JSON object. DTO class fields and these keys must be same. Let's go to customer DTO. See, customer name, email, and address. We will use these fields. Let's copy this. Let's paste here, and we can provide customer name Swami. And next one is email. Simply I'm writing like this. This is email ID. And next one is address. Copy this. Let's paste here. Address is like this. This is the post request. Let's click on send button. See, here we got the response from the REST API. Let's go to MySQL Workbench and let's verify whether the record is successfully inserted in database or not. Let's move to MySQL Workbench. Refresh schemas. See, this is the customer table. Here record is inserted in table successfully. And let's go to Postman again. And I'm changing some names. Tarak 123 Pune. Click on send button. See, this is second response. Go to MySQL Workbench and execute this command. See, second record also inserted. Let's go to STS ID. See here, insert queries are printed over here. We have successfully tested our create customer REST API. Okay, I will see you in the next video. Hi everyone, welcome back. This is the customer resource design. Here, this is get all customers REST API. It will handle HTTP GET method and URL path is /API/customers and its status code is 200 OK. Now let's implement get all customers REST API. Okay, let's move to STS ID. Let's open customer service. Inside this interface, I'm declaring one method that is list of customer DTO. The method name is get all customers. Here we no need to give any parameter as of now. Let's go to its implementation class, that is customer service IMPL class. Let's override get all customers method, control space enter. This is a method that we need to implement here. We'll get all the customers from the database. Then what we need to do is we need to call find all method, that is customer repository dot find all. It returns list of customers. Here we need to convert list of customers into list of customer DTO. For that, here we will use stream method, that is customers dot stream. This is Java Stream API and I'm using map. We'll use it to map entity to DTO using lambda expression. Here I'm using model mapper dot map. Here I'm taking customer. I want to convert into DTO, that is customer DTO dot class. Let's collect the result. For that, collect collectors dot to list. Here I'm directly returning here. Now I'm ready with get all customers method. Let's go to controller class. Here let me implement get all customers REST API. Here I'm implementing one method, that is public response entity. Here I'm passing list of customer DTO and method name is get all customers. On top of method I'm using @get mapping annotation. It will handle HTTP GET requests. Here I'm returning object of response entity, that is new response entity. Here I'm calling service method customer service dot get all customers and HTTP status is OK. This status will provide 200 OK. Now I'm ready with get all customers REST API. Let's start the application. See, now the application is up and running. Let's go to Postman tool. Here I'm changing HTTP method to get and constructing URL, that is http ://localhost 8080/API/customers. Let's click on send button. See, this is the customer data and we can also consume this data using browser also. because browser supports GET requests. Let's copy this URL. Let's go to browser, paste here, enter. This is the data that we are fetching from the database. Let's go to IDE. This is SQL select query. Like this, we will implement get all customers API. Okay, I will see you in the next video. Hi everyone, welcome back. This is the customer resource design. Here this is get customer by ID REST API. It will handle HTTP GET method. The URL is /API/customer. Here we need to provide ID. The status code is 200. Okay, now let's move to STS ID and we'll implement get customer by ID REST API. Let's go inside service interface, that is customer service. Here I am declaring one method, that is customer DTO, and the method name is get customer by ID. Here I am passing ID as the argument, that is integer customer ID. Here I am passing ID as the argument. Let's go to its implementation class. Let's override the method, that is get customer by ID. Control space enter. This is the method. Now we will get customer details based on ID from the database. Here I am using find by ID method. So for that, customer repository dot find by ID. If the ID is not available in the database, it will throw some exception, that is, or else here we need to provide one supplier. Here simply I am throwing an exception, new runtime exception. As of now I am throwing this exception. As of now I am throwing runtime exception, that is customer not found with ID. That is customer ID. It returns customer object. Finally, we can convert entity to DTO. For that we are using model mapper dot map customer. I want to convert it into customer DTO dot class. So directly here I am returning. Let's remove this. Here instead of throwing runtime exception, let me create one custom exception. Let's go to exception package. Here I am creating one class, that is resource not found exception. Resource not found exception. And it is extending from runtime exception. Here I am declaring zero argument constructor and also argument constructor, that is here I am passing string message, super of message, and we can add defaults here ready like this. We are ready with resource not found exception. This is custom exception. I will use this custom exception in service IMPL class. Here instead of throwing runtime exception, directly I am using this exception. Now I am ready with get customer by ID method. Let's go to controller class. Here we will implement get customer by ID REST API. Here we will implement get customer by ID REST API. For that I am implementing one method, that is public response entity. Here I am passing customer DTO get customer by ID. Here I am passing integer ID, and here I am using @path variable annotation. This annotation used to extract the values from the URL and assign the values to this method. On top of method I am using @git mapping annotation. It supports HTTP GET requests. Here I am passing ID. This is URI template variable, and here we can provide ID like this. I am returning new response entity. Here I'm calling service method, that is customer service dot get customer by ID. Here I'm passing that ID, and here I'm providing HTTP status. Okay. Now I'm ready with get customer by ID REST API. Okay, let's start the application. Right click on the project, run as Spring Boot application. Now the application is up and running. Let's go to MySQL Workbench. Here in the customer table we have two records, ID1 and ID2. Let's go to Postman tool. Let's copy this URL and opening new tab. I'm selecting HTTP method get and paste this URL. Here I'm passing ID1. Click on send button. This is the customer details belongs to ID1. I'm giving ID2. Let's send. This is another customer data whose ID is equals to 2. And this GET request will be supported by the browser also. Let's go to browser. Let's paste this URL here. Hit enter. See, this is the customer data. In MySQL Workbench, we have two records only. Here I'm giving ID 200. Let's enter. See, this is the exception, that is resource not found exception. Here, customer not found with ID. This is very lengthy exception and it is not readable. And we can also customize this exception. As of now, it is working as expected. Let's go to ID. This is SQL select query. Our REST API is working as expected. Okay, I will see you in the next video. Hi everyone, welcome back. Here this is the customer resource API's design. Here this is update existing customer by ID REST API. It will handle HTTP put method and URL path is /API/customer/ we need to provide the ID and its status code is 200. Okay, now let's implement update customer REST API. Okay, let's move to STSID to implement update customer REST API. Open customer service. Here we can declare one method, that is customer DTO. The method name is update customer. Here I am providing ID, integer customer ID, and I am providing DTO, customer DTO, as an object. Let's go to its implementation class. Let's override this method. Control space enter. Here we need to update the data into the database. First of all, we need to fetch the data from the database. So here I am copying this piece of code. Let's paste here. Now let's set new data to the existing customer, that is customer dot set customer name. We are reading from customer DTO dot get customer name. Similarly, customer dot set email, customer DTO dot get email, and then customer dot set address, customer DTO dot get address. Save new customer data in the database. For that, I am using customer repository dot save. This save method will act as, if the record is not available in the database, it will act as save. If the record is already available in the database, it will update the existing data. Here I am providing customer entity returns new customer, that is updated customer. Now we need to convert entity into DTO. Convert entity to DTO. For that I am using model mapper dot map, converting this updated customer into customer DTO dot class. Directly I am returning here. Let's delete this line. Now I am ready with update customer. Let's go to controller class. Here let me implement update customer REST API. That is update customer REST API. Here I am implementing one method that is public response entity, and I am passing customer DTO, and the method name is update customer. And here I am passing integer ID and customer DTO as an object. On top of method I am using put mapping. It will handle HTTP put requests, and this is URI template variable. Here I am using path variable annotation ID. It will read the values from the URL and assign to this method. And here I am using @request word annotation. This annotation is responsible to convert JSON data into Java object. Here data I am return new response entity. Here I am calling service method that is customer service dot update customer. Here I am providing ID and customer DTO as an arguments, and HTTP status is OK. It will return 200 OK. Now I am ready with update customer REST API. I want to test this API. For that, let's start the application. Now our application is up and running. Go to Postman tool. Here I am changing HTTP method to put. Let's construct URL to make put request. That is http://localhost 8080/API/customers. I want to change record number 1. For that, we need to execute post request. Here I am inserting one more record, Karthi. Karthi 123 Pune. Hit send. See, inserted new record. Let's go to MySQL Workbench. Let's refresh. That record inserted. The name Karthi. Let's go to Postman tool. This is ID number 3, right? Here I am changing ID to 3. I am using this JSON data copy. Let's go to put. Click on body raw JSON. Let's paste here. Here I want to change the details. I'm changing Karthi to Karthik, adding K. I'm changing mail ID also. In place of 123, I'm giving 555. In place of Pune, I'm giving Chennai. Click on send button. See, changes are updated. Let's go to MySQL Workbench. See, this is old data before refreshing table. Pune, Karthi 123. Let's execute the command. See, this is the updated data. Address changed to Chennai, Karthik 555. Let's go to IDE. See here, updated query printed on the console. That means our REST API is working as expected. Okay, I will see you in the next video. Hi everyone, welcome back. This is the customer resource API design. Here this is delete customer by ID REST API. It will handle HTTP delete method, and URL is /API/customer/ID. Here we need to provide ID dynamically, and its status code is 200 OK. Okay, now let's develop delete customer REST API. Let's move to STS ID. Open customer service. Inside this customer service interface, I'm adding one method that is void delete customer by ID. Where I'm passing one argument that is integer customer ID. Here I declare this method. Let's go to its implementation class. Let's override the method that is delete customer by ID. First we need to fetch data. For that I am copying this piece of code. Copy. Let's paste here. Now let's call delete by ID method from the JPA repository. That is customer repository dot delete by ID. Here I am passing customer ID. That's all. Now I am ready with delete customer by ID method. Let's go to controller class. Let me implement delete customer by ID REST API. Let me implement delete customer by ID REST API. For that I am implementing public response entity. Here I am taking string as type and the method name is delete customer by ID, and I am using delete mapping annotation. Here I am passing URI template variable. This is URI template variable. It will read data dynamically. Here I am passing ID as an argument. Here I am using @path variable. It will read the values from the URL and assign to this method. From this controller class I am calling service method, that is customer service dot delete customer, like this. Finally I am returning response entity dot OK. Simply here I am writing customer deleted successfully with ID, like this. Let's save this. Now I am ready with delete customer by ID REST API. Now let's test this API. Now start the application. See, our application is up and running. Let's go to MySQL workbench. Let's execute this query. See, as of now we have 3 records. The customer names are Swami, Tarak and Karthik. Okay, whose IDs are 1, 2, 3. Let's go to postman tool. Here let me take new tab, click on plus symbol. Here I am changing HTTP method type to delete. Here let me construct the URL, that is http://localhost:8080/API/ I want to delete the customer whose ID is equal to 3. Hit send button. See, customer deleted successfully with ID 3. Let's go to MySQL workbench. Let's execute this command. The third record is removed successfully. And let's go to postman tool. Here I am giving second record. Here I wanted to delete customer whose ID is equal to 2. Let's hit send button. Customer deleted successfully with ID 2. Let's go to MySQL workbench. Let's execute this query. See, second record also removed from the table. Let's go to ID. See, delete query printed on the console. REST APIs are working as expected. Okay, I will see you in the next video.